Hey everyone, how's it going? Today we will be solving another Leetcode challenge, which is reorder power of 2. So we are given an integer n, and we want to reorder the digits in any order, including the original order, such that the leading digit is not 0. And we want to know if after we reorder the digits, does this reorder number can be a representation of power of 2. So based on the example, we have input n equal to 1. We return back true because n and a 1 can be represented as 2 of power 0. And for n equal to 10, we return back false, even though we can reorder the digit into from 10 to 0, 1. This 0, 1 can be represented as 2 to power 2 to the power of 0, but because of the leading 0 here, that's mean it's not it doesn't comply to the rule, so that means we return back false. Let's have a look at another example. So if the given n is 46, then it means we can reorder it into 64, and 64 is can be a representation of 2, that is 2 to the power I believe it's 2 to the power 6, and then we want to return back true. Yeah. So like in this problem, I'm going to show you two solutions. One is the recursive permutation way, another one is the optimal solution. Okay, so now how do we come up with a brute force approach? So our brute force approach will be a recursive permutation. The first thing that we want to do is to turn the input digit. Let's say, for example, our n is equal to 46, and it can be rearranged into 64, which is a representation of power of 2. And we need to turn it into a string, and then we count it. So in this string, we have the value of 6 is 1, and the value of 4 we have 1. So we start our decision tree with an empty string, and in every subtree, we will start with any order of the number first. So let's say, for imagine that on the left subtree here, you want to start with digit 4. And for in the right subtree here, you might want to start with a digit 6, because the count of these two digits are still greater than 0. So now you have used 4 on the left subtree. That means the remaining number inside the count will be only 6. So that means here your 4 will be decremented to 0 and 6 will remain 1. That means you can only use digit 6 only. So like in this subtree, you will use number 6, and then you will get the result of 46. Then you check if 46 is a representative power of 2. It's not, then here you will return back false. So on the right subtree here, you have used number 6, so the remaining number is 4. So that means you will end up with 64, and you check if 64 is a representation of power of 2. It is, then you want to return back true. So in every decision tree, we only need only one true. If you get at least one true, then it's mean your input of n, you return back true to the root of the tree. Yeah, this is pretty much how we go about doing it in a recursive way with a permutation. The next one, I'm going to show you how we can come up with an optimal approach. Keep in mind that this solution, the time complexity of this solution is O of n factorial. That's because, for example, you have n equal to 46, that is 2 digits. So whenever you use 1 digit, it's always like you start from 2, then the remaining digits will be 1. So it's like 2 factorial. Right, so now let us look at the optimal approach. So for the optimal approach, we get a hint for the constraint. Remember that in the problem's description, it says that n is between, it should be greater or equal to 1, and the upper boundary is 10 to the power of 9. So we determine that the closest number to the power of 2 is 2 to the power of 30, which is this value itself. So the trick here is you want to create all the, possible value to the power, like the range to power of 2 from range of 0 all the way until this, this maximum value. And after you created kind of like this lookup set, you can determine that if the input n kind of like if that input n can be exist in this lookup or not. So how do we do that? So let's have a look at this example where the input n is 46 again. So before we check if this n is can be a representation of power of 2, we create this lookup, and our lookup will look something like this. So we have 1. No, it's not. N does not exist in this lookup. It's not 1. It's not 2 as well, and it's not 4. It's not 6. It's not 16, and it's not 32. But it's supposed to be 64, right? But the thing is, n equal to the 46 is not 64. That's mean for every value that you created in this lookup, it's supposed to be sorted. And when it's sorted, you can check, okay, now 46 is in the lookup, then you can like quickly return back true. So what if the input of n is 64 and not 46? That means you also have to sort the input n as well, which is 46, so that you can have this value in the lookup set. And that's mean because it's a set, so we can return back true. And the time complexity of this is O of 1, and the space is also O of 1. The reason why it's O of 1 because no matter how large or how small is the input, we always create a lookup. The lookup from 2 to the power 0, range from 2 to the power 0, or all the way 2 to the power 0. So there's supposed to be like at least 30 value inside this lookup. So that's why the space does not change, and the time complexity does not change either. Yeah, I think that's pretty much how the optimal solution look like, and now we can get into the coding part. All right, so now I'll code up two solutions for you. So the first one will be the recursive permutation solution. I'll just create a function called recursive permutation, and it will take an input of n. So the first thing that I want to do is to pass the n into a string. And after that, you want to create a counter dictionary where you count all the digits that belongs to n. And I'll want to create another helper function, which is a power of 2. That will take n as well. And what you want to return here is the bitwise AND operation. So if you don't get this bitwise operation, please just take a look at my video from yesterday, which is an easy problem that check if the number is the power of 2. Yeah. So after I create this helper function, I create another helper function called backtrack. That's how I usually name for the decision tree. That will take an input num and it will take the input count. So now we need to write our base case. So the base case is when the length of this num is equal to the length of the original string, which is the length of digits here, which is when the size of the length of the string are both the same. We want to return, we want to call this is power of 2. So we need to cast it into an integer first before we pass it to this function. Okay. Next, what we want to do is we want to loop through every digit in our count, and we need to check if this count of this digit is greater than 0. That means we can use this digit. So before we call the recursive function, we need to decrement it by 1. And then we call our backtrack recursive function, and we will add this digit to our string and pass the count. And after we finish our recursive function, we can kind of like add it back to our frequency. Yeah. Then we can return fault, but here you want to check as soon as you find any value that is a power representation of 2, you can just return back true immediately without having to search for other value. Okay, so now I can kind of like write another for loop outside and check for a digit in count, because remember that the rule, we do not want any our digits to start with 0. So I'll check if digit is not equal to 0. Then here we decrement the count by 1, and we check again if backtrack if digit and count, and then we return true. And after that, we want to add it back to our count. Otherwise, just return false. Yeah, first, before we write code up our optimal approach, let's just run to see if this naive approach work for us. So I'm just gonna call recursive permutation, and I hope I didn't make any typo mistake here. Okay, let's just return and see if that works. Okay, I made some typo mistake. Okay, let's just copy the name up here. I still make mistake for a typo. Okay, let's see. Okay, so now it passed the initial test cases, and let's just submit if it's passed all the test cases. Right, so it passed the test cases, but it's not optimal. So, okay, I'm gonna show you how we can implement the optimal approach. Okay, so now for the optimal approach, I'm just gonna, yeah, I'm not gonna create a function. I just do it in same thing. Just pass the input n into string, and I'm still gonna create a counter taking the frequency of all the digits, and I create a lookup, which is the set itself. So first I'm gonna loop from I in range from 0 all the way to 30, and I just gonna, first we need to turn it into string. I need to sort it and take power of I here. Yeah, so sorted power. I hope I close all the parentheses here. Yeah. So here you need to kind of like cast it back into the string, and then you sort those string and put those value inside the lookup. So call lookup and add the value to it. Yeah. So I think that's pretty much for our lookup. Then for the end, it's very simple. You need to pass it into a string and then you sorted it. So we can do similar to how we did it in for power of 2. Then you can just return n in our lookup. Yeah. Let's see if the solution passed the test cases. Okay, now let's just submit it and see. Cool. It passes all the test cases and it bit 100%. So that means it kind of like it kind of indicate that this is an optimal approach. So yeah, that's pretty much it for this solution. So if you like it, please subscribe and don't forget to give it a thumbs up. And I'll see you in the next daily challenge. Thank you so much.